Hi and welcome to the Dutch PHP Conference 2020 edition. We're so glad that you've chosen to be here with us today. We hope you find it a valuable investment of your time. We've got a great speaker coming up for you, but real quick, I want to give a huge shout out to my buddies at iBuildings for putting on this conference all these many years. I've been involved in this conference since about 2007 when I spoke at one of the first ones and just absolutely love it. It's one of my favorite PHP conferences ever, and one of the main reasons that it's my favorite is that iBuildings puts on a great conference. So Tom, Yoni, and Angela, and all the iBuildings staff, thank you all for all the hard work that you've put into this. Finally, it is my pleasure to introduce to you Sergey. Sergey is the author of Learning Event-Driven PHP with ReactPHP. I'm very excited to see what Sergey is going to present to us. Sergey, go ahead and share your screen and take it away.
Hi, everybody. Thanks for joining. My name is Sergey, and today I want to talk to you about asynchronous PHP and ReactPHP. We'll cover the basics of asynchronous code and how it may work in PHP. We'll discuss pros and cons of going async and how we can improve performance of the already written synchronous PHP application using a synchronous approach. I think that nowadays in PHP community, there is no common agreement about asynchronous code. One part of the community considers asynchronous PHP as something new and interesting that can solve some performance issues, while another part of the community is strongly against asynchronous PHP and suggests using Node.js or Go for solving performance-sensitive tasks. Let's try to understand why this happens, why many people don't consider PHP as a suitable tool for solving asynchronous tasks. As for me, I like PHP and I want to use it to solve different tasks. Also, I don't want to limit myself with request-response cycle. Moreover, I don't want to extend my stack with a new language with its own ecosystem just because someone on Twitter or on Reddit said that PHP is not the right tool for my problem. And the most popular reason, I think, is that PHP wasn't created for that, for these sort of tasks, that PHP is only about web and rendering HTML pages. On the one hand, yes, it's hard to argue that PHP wasn't designed to be asynchronous. Truth be told, it also wasn't invented as a language for creating large and complex applications. Let's be honest, in those times, there was no JavaScript at all, and people even didn't think about asynchronous stuff. Everybody just rendered HTML synchronously, and people were happy with it. But since then, almost everything has changed. It is 2020 now, we have Composer with huge community around it, and the language itself has evolved a lot. Now we have powerful frameworks that help us to create really complicated enterprise applications. And step by step, PHP is no longer only about request response. Now we have backend and frontend. We develop different APIs. We make different integrations with other infrastructure systems. And of course, CLI commands are a very common thing nowadays. And furthermore, the requirements for our programs have also changed. Now we count milliseconds and want our scripts to execute very fast. But how does asynchronous code help us here? How can it improve application performance? And to better understand this, let's classify what types of execution we have. We have synchronous execution with one thread. This is how traditional PHP works. We have asynchronous execution, still one thread, but we add concurrency here. This way, Node.js and ReactPHP work. And we may have parallel execution with many threads. For example, Python can work this way. So to better understand the difference, we can use an analogy with a restaurant. Let's imagine that there is a customer who wants to eat spaghetti and meat. So we have a kitchen that represents our program, and we have chefs that represent the threads. In a traditional synchronous PHP application, we have one single chef. He goes to the kitchen, goes to the stove, puts a pot of water, then sits down and waits for water to boil. As soon as water boils, the chef takes spaghetti, puts it into a pot, and waits for spaghetti to cook. When spaghetti is ready, the chef proceeds to the sauce, puts it on the stove, and again sits down and waits until the sauce is cooked. So in general, the picture is clear. The chef does everything sequentially in order. One action, then another, then the next one, and so on. In an asynchronous program, things happen a little bit differently. As before, we have one chef. The chef fills the pot with water, puts it on the stove, but this time, instead of sitting and waiting for the water to boil, the chef immediately takes another pot, fills it with sauce, and puts it on the stove. And only then the chef stops and sits down and waits for any of them to boil, because at the moment the chef has nothing to do. And with a parallel program that uses multiple threads, there will be several chefs in the kitchen. One of them can cook spaghetti, while another one is cooking meat. Each of them can perform their own task completely independently. We are going to cover the asynchronous approach in this talk when we have one chef in the kitchen who is constantly busy doing something. The advantage of this approach is that if we compare it with multi-threading, then in theory, we can do more in the same period of time, because our thread will be constantly busy doing something. This way, we maximize the use of resources. Parallel execution with several threads is quite complicated in terms of writing code. You need to synchronize threads, reallocate memory, and so on and so on. While in theory, everything should be done parallel and quickly, but in reality, chances high that it will become just a mess. So let's consider a more realistic example. Imagine that we have some kind of a console command, a long-living script that endlessly requests several data sources, some APIs, processes the results, and stores them in the database. We need the most relevant data in the database as soon as possible. It is critical for us. For example, we analyze the prices from different stores to provide the best discounts based on this data. What is the traditional way of doing it, synchronous way? We sequentially make requests to APIs, sequentially process responses, and then sequentially store results in the database. I mean, we start with the first request, then wait until it is finished. We process the response, save the result to the database, and only then we start executing the second request, and then the third one. What is the downside of this approach? Here, our program actually is constantly waiting for something. We wait until HTTP request is completed, then we wait until data is saved to the database. And during this task, the execution flow is stopped and blocked. The program waits and thus it does nothing. As a result, the total execution time of this code equals the sum of the time spent on all three requests. The asynchronous approach uses the concept of non-blocking I/O. When read-write operations, they don't block the flow. What does this mean in our case? We don't waste time waiting for one request to be executed to start another. We send the first request, and while it is being executed, we can immediately send the second one and the third. And while requests are executing, the execution flow can be busy with something else. Once the requests are completed, we can go back and process their results. With this approach, we wait only for the slowest request instead of waiting for the sum of all three requests, like we did in the previous example. So sounds interesting, right? But what does it mean, this non-blocking input-output? How can I run tasks without waiting for them to be completed? And the fact is that input-output operations are rather slow. As a rule, they are executed many times slower than calculations. For example, when we discuss operations that our CPU does, we use nanoseconds. But when we deal with network, such operations are measured in milliseconds and sometimes even in seconds. So the difference is really huge. What do I mean by I/O, input-output? Read and write operations that actually any program has. API calls, interactions with the file system, database queries. Thus, programs written in a traditional blocking way, they spend a lot of time waiting for response from disk until a network request is completed. And if performance is critical for us, and if we want to speed up the execution, then we need to somehow start such operations in background, execute them asynchronously. How can this be implemented in PHP? Well, we can ask the operating system to process all operations related to I/O. For example, we need to read data from a file. If we don't want our PHP script to wait for the file system, we don't directly communicate with it. Instead, we go to operating system and tell it, open the stream in the file system, please, and read this data from it. As soon as the data is read, let me know. And that's it. Then our script can go away and do something else. Once the operating system does its tasks, we will receive an event from it saying that, okay, the data is read, so we can come back and process it. And to be able to listen to such events, to be able to come back and process them, we need a special architecture, event-driven architecture, which is used, for example, in Node.js. Here, PHP and Node.js have something in common. Both are executed in one single thread. Only one task can be executed at a certain moment in time. And this doesn't really limit us. Everything that can be performed slowly, input-output, will in fact be executed not by our PHP script, but by the operating system. We will only process events received from the system. Let's consider this approach in detail. All work, all interaction between different parts of the code in such an architecture is built on events. We have one running process, our PHP script, with a running event loop. The event loop under the hood is just an endless loop that listens to specific events and calls handlers for them. For example, we have some kind of input-output task, reading a file. We start it and tell the operating system to read the data from this file. That's it. Then the execution thread can do something else. We started this task and don't wait until it is completed. Once the operating system read some portion of data from the file, it sends us an event with the data that has been read. A record of this event is added to the queue. The execution thread takes the first event from the queue and calls the corresponding handler for this event, our code. For example, we calculate something based on this data, and the handler itself can also start, for example, 2 more I/O tasks. Let's say we want to send this data via HTTP. And this new task can also generate their own events. Once the event handler is completed, the thread returns to the queue and takes new events that have occurred while the thread was busy. And the loop executes until it has something to do. Either tasks are performed in the background or something else hasn't been processed in the queue. As soon as all tasks are completed and the event queue is empty, the loop stops. And having this kind of architecture, we can start several I/O operations, and we don't need to wait until they are done. Instead, we will know about their completion through events. And then we can go back and respond to these events. We don't waste time anymore. These I/O tasks, they will run in the background for as long as they need. So what about PHP? Of course, in the language itself, we still don't have built-in support for writing asynchronous code. Yes, there are really low-level things, but we don't have such high-level abstractions like event loops, streams, and promises. But this doesn't mean that we can't use PHP to solve asynchronous tasks. With the rise of Composer, the problem with the lack of tools was solved by the community. And ReactPHP is the tool that makes it easier to write asynchronous code in PHP. This is how it looks. Let's quickly consider a very simple JavaScript example to demonstrate asynchronous code. The setTimeout functions defers code execution, in our case, printing the word world. This code will be executed in the specified number of milliseconds. Here we have 0 milliseconds. So the common sense tells us that a delay of 0 seconds is basically the same as doing right here, right now. And we think that the word world will be printed first, and only then JavaScript will print the word hello. However, if we run this code, hello world will be printed. This happens because setTimeout is an asynchronous function. Actually, it executes nothing. Under the hood, it takes this callback and puts it into the queue to execute later. And like our chef in the kitchen who puts the pot on the stove and goes further, the code execution goes the same way, and the line that prints the word hello is executed next. Then the event loop looks through the timers queue, finds out that The delay of 0 seconds has already passed and runs this code. That's it. Here we break the traditional sequential flow. The second call of console.log will be executed before the call inside say timeout. And thus we receive the message hello world. And the exact same code written with ReactPHP looks like this. What's going on here? Examine the execution flow from top to bottom. At first, we create an event loop. Yes, in PHP, we don't have an event loop running in background. Therefore, we need to explicitly manually create it. Next, we add a timer indicating that after 0 seconds, this code should be executed. And then we print the word hello and manually start the event loop. At the time the event loop starts, the word hello is already printed. The event loop starts, it sees that the timer has already gone off. The corresponding event is fired, and in response to this event, this handler is called. The code inside set timer, and the word world is printed. With this simple example, you can see the basic structure of any ReactPHP application. We create an event loop once at the beginning. You write the code that uses an event loop. This part describes the behavior of our application, how we are going to react to different events. And in the end of the program, we start the event loop once. Let's remove the creation and the start of the loop, and it turns out that the code written in ReactPHP looks almost exactly the same as code in JavaScript. The only difference here is that in PHP, we need to explicitly create and run the loop. To get the result of a synchronous process in ReactPHP, we use the concept of promises. I think that most of you are already familiar with promises from the JavaScript world. So let's quickly refresh what promises are, and then we will look at how it works in ReactPHP. Consider the following example. Imagine that you come to a well-known fast food restaurant and you decide to order something, for example, a burger. So you pay for it and expect to receive a burger in return. But the cashier gives you only a check with your order number on it. So consider this check as a promise to a future burger. And so you take this check and start thinking about your burger. You don't have it yet, so you stand there and wait until your order number appears on the screen. And only then you can exchange your check, your promise, for a burger. So a promise is just a representation of some future value, a time-independent container that we wrap around the future value. For us as a client, in fact, it doesn't matter whether we have this value or not. We behave as we already have it. Let's consider another example, some PHP script. In the beginning, we create a loop. Then we instantiate an instance of class browser. It is an async HTTP client for ReactPHP. Consider it as a sort of ReactPHP guzzle. So we send an HTTP request, which is some kind of task that may take some time to complete. And this task may succeed and return something in response, but it may also fail. And since the task is performed asynchronously, we don't have access to its result here. Instead, in response, we get a placeholder for the result, and we can use this placeholder as if we already have this result. Then, once the task is completed, the placeholder will be replaced with the actual value. So it turns out that the promise depends on the state of the process that gave us this promise. It can be waiting when the process is still running. It can be resolved when the process is done, and the promise can be rejected when the process fails. Everything the same we have in Node.js. From the client code, we can react to these changes in the state. Promise API looks exactly the same as in Node.js. We can write this declarative code. We declare that as soon as the process, the GET request, is completed and we get the result, then we need to perform some action. Method then can also take two arguments. The first callable will be called when some deferred process succeeds and it receives the resolution value. And the second callable will be called when the process fails and it receives an exception that was the reason of the failure. Promises play a very important role. They allow us to control asynchronous execution. PHP runs in a single thread, which means we don't have to deal with all this complexity associated with multi-threaded programming. But on the other hand, we need to somehow manage this asynchronous execution and coordinate actions in the application. For example, when we execute two parallel HTTP requests, this is usually simple to do. But problems come when we need to streamline the responses of this request. For example, when one request requires data received from another request. And promises allow us to solve this problem with a chain of then calls. From method then, we return another promise. Here we don't care how long it takes to complete the first request, less than a second or an hour. Promises, they hide these details from us. We just declare what and when needs to be done. As soon as the first request is completed, take its result and send the second request. Another basic abstraction in asynchronous code is streams. When I say stream, the first things that come to my mind is video streaming. This is a very common example. We have some big amount of data, for example, a movie file, and the client. The client wants to watch the movie in the browser via HTTP, but the client doesn't want to download the whole movie at once. Instead, we break this large file into pieces or in chunks. Thus, we load several parts into the buffer. Then, when the buffer is full, we send it to the client and repeat this way until the whole file will be sent. Streams play an important role in event-driven architecture. They allow us to process large amounts of data in chunks. And actually, under the hood, streams are just collections of data, something like arrays. And the only difference is that stream data may not be available at once, and therefore streams don't have to fit in memory. All this makes streams an ideal tool for working with large amounts of data that constantly come from some external resource. For example, when you need to process a huge log file, then there is no need, and even in a synchronous application, it would be stupid to load it entirely into memory. It would take some time and resources. Instead, we read it through the stream and receive notification in event each time a new piece of data is ready. In this case, it will be a readable stream. If, for example, we upload a file and continuously write data on disk, it will be a writable stream. There is also a bidirectional or duplex stream in which you can both read and write, for example, a socket connection. Streams API looks very similar to Node.js streams. Essentially, streams are event emitters. When something interesting happens inside, it can respond to this event. Let's continue with our example with an asynchronous HTTP request. In response, we get a promise that resolves with a readable stream. Why with a readable one? Well, because we can't write into HTTP response, right? So in order not to block the flow in case, for example, when we have requested some heavy resource, we get the response body as a stream in chunks. To read these chunks, we add a handler to data event, which occurs whenever there is a new portion of data available for reading. So we call method on, specify the name of event. Here we have data event, and we add a handler for this event, a callable. In my case, I just print receive chunk of data. And it turns out that while we are reading data from the stream, the application itself doesn't freeze and continues to listen to other events. We read a piece of data, and then the event loop switches to something else. Once a new chunk of data becomes available, the loop switches back to the stream again. And once the whole stream is fully read, it closes, and fires close event, we can also react to it. Writing to writable stream looks very easy. We call method write and provide the stream. Very simple. So these were the basic low-level abstractions, on top of which essentially all asynchronous code is written. We can consider them as building blocks of any ReactPHP application. But ReactPHP ecosystem is not limited to them. We already have high-level components for different types of tasks. Components for working with storage, network, queues, There are asynchronous caches, logs, even different stream implementations, for example, JSON stream. And most likely there is an already written component for your case. You only need to add your business logic. To take advantage of ReactPHP, it's not necessary to take and rewrite your entire application to streamlined promises. And in fact, I wouldn't recommend doing it and making your app completely asynchronous. This is a really difficult stuff. Instead, it will be much better to find bottlenecks where you have performance issues and try to fix them with ReactPHP. Let's get back to the application that we reviewed at the very beginning. We have a script that constantly requests 3 data sources, processes the results, and saves these results to the database. And performance is critical for us, and we want results to be in the database as soon as possible. And here it's obvious for us that the bottleneck is input-output operations, those slow synchronous HTTP requests. So take a look at this code. This is some kind of component inside the application, an interface which receives a list of APIs, URLs, and returns the prices. Take a look at the synchronous implementation. Inside it uses Guzzle client, and under the hood, we sequentially make several requests to provided URLs. Here in the loop, each time, Here in the loop, the execution flow stops and waits until each HTTP request is finished. So, well, we can try to rewrite only this small piece of code with ReactPHP. How will it look like? The asynchronous implementation of the interface. Now in the constructor, we inject an asynchronous ReactPHP HTTP client and an event loop. Why do we need an event loop here? Wait a bit, it will be clear soon. Now, instead of responses, we have promises. Inside the loop, we start asynchronous HTTP requests. This time, the execution flow doesn't stop in the for each loop. We want to run all 3 requests at the same time and only then wait until they are done. In fact, in the loop here, we don't send the request. We just describe how a synchronous piece of code is going to work. And next comes ReactPHP function waitAll. It is something like a wait from Node.js. This is the reason why we injected an event loop. And this is the most interesting part of code. Under the hood, the event loop starts running. Our requests are sent. And then the event loop will be running until these promises that are passed here are fulfilled. Or in other words, until these HTTP requests are done. As a result of this function, we get an array of responses. And then we go back to the traditional synchronous execution flow. So let's recap. We collected data asynchronously and then continued to synchronous flow. Amazing, right? And of course, you can say that I'm reinventing the wheel here, that the same things can be easily done with Guzzle. Why do we need ReactPHP for this sort of stuff, for making asynchronous HTTP requests? And I will say, yes, you're absolutely right. With Guzzle or even with multi-curl, you can send HTTP requests asynchronously. But we can go even further. We can make the whole data processing flow asynchronous, starting from HTTP request and then ending storing the data in the database. Let's try. Imagine that there is some kind of service that completely encapsulates the whole process. A request to API processing the result and saving it to the database, and does all these things asynchronously. Let's call it, I don't know, price scraper, for example. It will encapsulate an asynchronous HTTP client and some asynchronous database storage. Then we have a method that accepts a URL as an argument. So what happens next? First, we make an asynchronous HTTP request that returns a promise. And from this moment, we work only with promises, because everything here happens asynchronously and we need to somehow manage this execution. Once the request is executed, process the result. Once the result is processed, save to the database, and so on. So the HTTP request returns a promise that resolves with a response. Next, we process the response and build an object from it. And we return it from the promise. It means that this then call returns a new promise that resolves with an instance of class prices. Then we get this object and save it into the database. We also access the database asynchronously. Therefore, at the end of all of this, we also receive the resulting promise. And this promise resolves only when the data is saved to the database or rejected if somewhere something has failed. And this resulting promise can resolve with an ID of record, with the record itself. It is not important here. Further, in the higher level components of the application, we can decide ourselves how we can to manage this promise. For example, we can limit the number of concurrent promises and start to process only 50 requests at a time. And so the bottlenecks were fixed, and there is no need to run the entire application asynchronously. Even the application architecture hasn't changed. Perhaps high-level components don't even know that this part inside works asynchronously. So if everything is so cool, then let's make all projects asynchronous. Everybody wants to have high performance, right? But with great power comes with a great responsibility. And the biggest challenge we will face in PHP is blocking calls. Since the code executed in one thread and any long-running operation blocks the entire event loop. The event loop must be constantly running, listening to new events and calling handlers for them. When one of the handlers runs too long, all other handlers wait and new events are not processed. And unfortunately, most of the functions and libraries in PHP were written to work in a traditional synchronous environment. Thus, they block the flow. For example, you can't use sleep function if you want to delay some execution. Instead, you should use timers. Any network communication blocks the flow. Actually, because of this, you can't use PDO and everything written on top of PDO. I don't know, eloquent doctrine, because under the hood, PDO makes this native HTTP requests. Instead, you should use stream-based clients that don't block the flow. You can't use all native functions working with the file system. So no file exists, fopen, file get contents, and so on. Instead, you should special asynchronous adapters for the file system. And also when using third-party libraries, you need to be very careful about what calls, what functions are used there, whether they can block the flow or not. In asynchronous code, as an alternative to blocking calls, there are the following rules. When we need to get some value, we use promises. When we need to access to some kind of API that constantly sends or receives data, we use streams. And this applies to asynchronous code in general. And if we are writing a completely asynchronous application, then there is still a set of pitfalls waiting for us. Memory management. People often complain that in PHP we'll definitely have memory leaks. Firstly, in the latest versions of the language, the garbage collector was significantly improved. And secondly, in fact, this is not PHP problem at all. You can get the same memory problems in Node.js, and memory management in long living processes is your responsibility as developer. You need to monitor, to optimize, to clean up, and use the resources. Closed connections with long living processes, your storage connections may be closed by timeouts, and it is necessary to somehow keep them open, maybe periodically check and reconnect if required. Error handling needs special attention. Traditionally, when we have a separate thread for each client, with each request, the framework boots, the controller runs, and if something fails, it affects only one, this request. All other connections, they possibly stay alive. But in an asynchronous application, for example, in case of a web server, if one connection caused an error, uncaught exception, then the entire application crashes and all clients are disconnected. Very bad situation. Also, while debugging, due to the fact that everything in the program happens asynchronously, it is hard to predict its behavior. It is impossible to say that exactly what and when will happen in the script. And of course, no more var dump and die. If you write that if the client API equals this, then we make var dump and die. Yes, so for one client, this code will be called, but again, it will stop the entire application and all the clients will be disconnected. Also keep in mind that all clients or processes in the asynchronous application, they share global state and share the same memory. Now, in PHP community, we have several libraries or solutions that you can use to write asynchronous code. And I think that these are the most popular: ReactPHP, AMP, and Swooly. Why I'm talking about ReactPHP today and not the others? Well, only two libraries from this list, AMP and ReactPHP, are written in pure PHP and can be installed via Composer. So if we compare ReactPHP and AMP, then ReactPHP has a more solid documentation. I think it is a huge benefit. In addition, ReactPHP has a strong, huge ecosystem with large number of third-party components. And the main difference between AMP and ReactPHP is that AMP uses the concept of coroutines, while ReactPHP uses promises. All interactions between components within AMP are based on coroutines and yield calls. Some people believe that coroutines are better than promises because they help to get rid of promise hell. One can argue, first of all, coroutines in PHP are actually just a hack that can be done with generators. And secondly, yes, the code seems cleaner, like a traditional synchronous code that we used to see. But with coroutines, the client code doesn't know anything about what it receives. There are no type hints. With promises, we at least know the interface, that in return from the component, we get a promise and it can either resolve or reject. But with coroutines, we get a generator, and the generator can return anything. Also, it should be said that with ReactPHP, you can also use coroutines, but with the help of third-party library. Another very important thing about ReactPHP is that it is not something completely new, unreliable with a bunch of bugs, not at all. The project itself is already quite old. Now it is, I think, already 7 years old. And ReactPHP is production ready. Moreover, it provides long-term support for its core components. So you can safely depend on them, receive fixes, updates, and don't worry about backwards compatibility. I think it is really, really cool and a solid reason why you can start using ReactPHP in serious and maybe enterprise projects. So to summarize, actually the idea of my talk wasn't to sell you ReactPHP. Despite the fact that I really like asynchronous PHP, I still understand that if you have the opportunity to use, let's say, a more suitable language for solve your asynchronous tasks, I don't know, Node.js or Go, then go ahead and use it. As for me, I suggest using Go because all this asynchronous magic is hidden from us inside the language. In Node.js, you still have to keep in mind this event loop ticks, that this thing happens now, this thing is going to happen the next tick, and so on. With Go, you don't care about this stuff. And talking about PHP, there are no native tools for writing asynchronous code yet, and I think they are unlikely to appear soon. However, if you already have a PHP stack, a team of PHP developers, and infrastructure for it, then you can consider asynchronous PHP. I mean, when adding one more language in your stack costs you too much. In this case, ReactPHP may be your choice. And my mission today was to show you that there are such tools in PHP that they can be easily used. There is no black magic inside. Just install it via Composer and you're ready to go. Moreover, the code itself even looks familiar to what we used to see in Node.js. And in cases when performance is critical for you, and at the same time you know that you are waiting for some input-output operations, whether there is a network request or file system call, and this blocks you, you can consider using ReactPHP. Perhaps an asynchronous approach can improve your application performance. And there is no need to complicate your stack with an additional programming language, just because you need to solve some kind of asynchronous tasks. Perhaps PHP can solve your problem, and there is no magic inside PHP, ReactPHP, and no additional extensions needed. It is written in pure PHP. But remember that you can't just plug ReactPHP into your project it will immediately start working 2 times faster. No, it doesn't work like that. It is necessary to fully understand the whole concept of asynchronous code in order to gain all the benefits from it. That's why I spend a lot of time in this talk explaining how event loop, promises, streams work. And remember that in a traditional synchronous application, there are a lot of blocking calls inside. If you try to rewrite such an application and make it completely asynchronous, you will definitely suffer a lot. Please don't do it. Instead, try to find bottlenecks inside your application. Often such bottlenecks caused by slow I/O. You can try to fix these bottlenecks with ReactPHP. Typically, an asynchronous piece of code can be very easily plugged into traditional blocking code. Thus, it will be possible to improve application performance with very little effort and without any architectural changes. Thank you for listening. If you are interested in asynchronous PHP and React PHP, you can visit my blog, where I have a lot of articles on these topics. If you don't want to go to the website and search for an article each time you have a question about React PHP, I have several books for you. They cover different topics and they are for different levels. There is a cookbook with different recipes for a lot of different cases. There is a book for beginners and so on. If you prefer watching instead of reading, I have a YouTube channel with screencasts about React PHP. And you can also follow me on Twitter, where I post all of this stuff. So I would like to answer your questions, if you have any. Let me see. I don't see questions.
Yeah, you've got several.
Can you read,
see.
please? Oh, I see. I see.
You see them?
Yes.
Okay, good.
What if I need an asynchronous behavior only on a single function, and I don't need asynchronous requests, queues, etc.? Oh, if you really need to run just one function with PHP and make it asynchronous, you can wrap it inside the child process. For example, file system adapters, they work this way. They just wrap all file system interactions inside the child process and communicate with it. So the PHP flow is not blocked for it. Is the React promise different from Gazelle HTTP promise? We are currently using Gazelle HTTP promise to pull requests and run this. Actually, I don't know. I can't lie to you. I don't know. I haven't seen what's inside Gazelle promises, but I think React PHP promises, they follow the standards A+, the Node.js promises, and if Gazelle follows the standards, so they will be compatible. Hey Sergey, hey, can you tell us a few words about Drift PHP? Is that a good choice for those who don't work with async PHP yet? Does the Drift PHP should be considered as a competitor for React PHP, or as it uses React PHP internally, it is like an abstraction? Yes, there is a framework, Drift PHP. It is built on top of React PHP and on top of Symfony components. So you can consider it from high level as a Symfony on top of React PHP. And if it is built on top of React PHP, I can't say that it is competitor for React PHP, because I think they solve different tasks. And as I know, for current moment, Drift PHP is still in development state. So you can install it, you can play around it, but we don't suggest to use it in production. But there is already a lot of stuff. So you can have controllers, queues. There is even a debug database abstraction layer. We have some drivers for Postgres, for MySQL, and for SQLite. So if you need, yes, you can install and use Drift PHP as a symphony on top of ReactPHP. Are there synchronized mechanisms like semaphores or monitors? Truth be told, I don't know exactly. I haven't used, and for me, there were no use cases for such mechanisms. Do you have any experience breaking large complex SQL queries of repos into smaller, more readable queries and running them in parallel using promises? Do you think could keep good performance? Yes, talking about SQL, you should keep in mind that the server, so yes, you have a stream-based clients, so you can send several SQL queries, right? But the server that receives your request, it is gonna execute them sequentially. So the first request comes and the server will execute it, and only then will start executing them. And working async, you can send several requests, let's say in parallel, but the server will process them sequentially. So you should keep in mind when starting breaking your SQL queries into smaller and try to make them asynchronous. What is your opinion on AMP and what would you recommend to use, AMP, ReactPHP, or any other for? I think I have answered already. When I started working with the Synchronous PHP, people talked about ReactPHP, and I just opened it, understood everything. I talked with Christian Luke, and he said that the team, I think, spent even about an year to write a documentation, completely full documentation for different use cases. You even can find examples in repositories. And for me, it was the choice to depend on these libraries. When you have good documentation, when you have a community, for example, you can ask the core members of ReactPHP on Twitter something and they will respond. You can make an issue on GitHub and they will respond. I think this community communication costs a lot. Even if ReactPHP uses promises and it looks for us that are familiar with sequential flow, it's hard sometimes to follow. When this is executed, this, then this, then this, it's hard, but you should wait the course. From one side, you have this, I will not say ugly interface, but promises, and from other hand, you have community open, which is open. We now have a lot of blog posts, books, screencasts. There was a course now. So I have chosen the community, not the code, actually. What is your favorite production project you built with ReactPHP? My favorite production project, we built a cryptocurrency exchange on top of ReactPHP, and it was really cool. It was, truth be told, it was built on ReactPHP and on top of DriftPHP. We had Symfony and we had a lot of concurrent requests, and Symfony limited us with performance. So we tried to migrate to asynchronous Symfony on top of ReactPHP. And truth be told, the improvement was really huge, but we understand the cons of it, that the project is still in development, that we are gonna have bugs, but the author of Drift PHP, you can talk to him on Twitter, you can, there is a GitHub channel, and yes, the community is also alive. Oh, so no questions more, I think.
No, I believe that was all of them. Hey, thank you so much, Sergey. I know everybody is just blown away, all the possibilities that you've just presented us, and which is good because now we have a short lunch break. We'll be back at the top of the hour. Until then, you can stare at the pretty slide there created by the iBuildings team, or you can go out to Joined In and you can leave Sergey and all the other speakers some feedback. Tell them what they did right, tell them what they can do better. We really appreciate that. Also, don't forget, if you're using social media, hashtag DPC20. That's capital D, capital P, capital C, 20. We'll be back at the top of the hour.